In this demonstration, I will be combining hydrogen peroxide, H2O2, dish soap, dry yeast, and warm water to essentially produce the remnants of H2O and O2 to produce the chemical reaction of H2O2 yields H2O plus O2. Before I combine my ingredients, it is essential in understanding the basic idea of this experiment. First, we are going to mix the concentrated hydrogen peroxide with a healthy dose of liquid dish soap. Then I'm going to add my catalyst, which is my yeast, to warm water and let it set. The hydrogen peroxide will break down really quickly. Hydrogen peroxide breaks down into oxygen and water. Since there will be oxygen trapped in the peroxide, this rapid decomposition will result in lots of oxygen that needs to be pushed out of the container. As the peroxide breaks down, the soap that was mixed in will also combine with the water and turn into foam. The oxygen gushing out is what makes the bubbles foam. Now let's begin with balancing our equation. Our equation states H2O2 yields H2O plus O2. That being, hydrogen peroxide yields water plus oxygen. In this equation, you are starting with the same amount of hydrogen on both sides, that being 2. But the unbalanced amounts come from oxygen. You have 2 in the reactants and 3 in the product. To balance this equation, it would be essential that we add 2 in front of H2O2, giving it 2H2O2 in the reactants, and place a 2 in front of the products and or product, H2O, giving H2O 2H2O. The final product will give us 4 hydrogen, 4 oxygen, yielding 4 hydrogen and 4 oxygen, making the equation fully and completely balanced. In this demonstration, vinegar is placed in a plastic bottle and a baking soda filled balloon is attached. The mixing of the baking soda and vinegar results in a balloon expanding. First, I'm going to place 2 tablespoons of vinegar in the bottle. Next, 1 teaspoon of baking soda will fill the balloon. The carbon dioxide will fill up the balloon once it is placed on the bottle, causing its volume to change and it to expand. The baking soda and vinegar will create a reaction that gives off a gas product. Vinegar HC2H3O is a solution of acetic acid. It reacts with baking soda, sodium bicarbonate, NaHCO3 to produce carbon dioxide gas, CO2, and an aqueous solution of sodium acetate, NaC2H3O2. Baking soda is a chemical called sodium bicarbonate and reacts with vinegar. Vinegar is an acidic acid. When these two chemicals react, they form something new. The following chemical reaction for this demonstration is as follows. NaHCO3 plus Hc2H3O2 yields CO2 plus H2O plus NaC2H3O2. In this chemical reaction and/or chemical equation, it is very complex, as it is also crucial and important that it is balanced correctly. First, we will begin looking at how much we have on both sides of the equation, how many we have on the product side, and how many we have on the reactant side. The equation in this reaction is already balanced on both sides, making the entire equation equal.
The eggshell experiment focuses on the reaction between an egg, its shell, and vinegar. The whole process takes 24 hours to 48 hours, while the shell bubbles in the vinegar while the shell is being ate up by the vinegar. When you react carbonate with acid, you are left with solute salt, carbon dioxide, and water. The shell slowly dissolves, producing bubbles of carbon dioxide. The equation for this experiment is CaCO3 plus 2CH3COOH yields CaCH3COO2 plus CO2 plus H2O. I have an egg right here and some vinegar, and we just simply place the egg in the vinegar and wait 24 hours until the shell flies. Here's the egg after it actually took 48 hours for this one to completely dissolve. But you can see that it's squishy, and you can see the yolk, right?
The chemical reaction in the eggshell experiment is as follows. CaCO3 plus 2CH3COOH yields CaCH3COO2 plus CO2 plus H2O. In this chemical equation, it is very complex, as it is also important that it is balanced correctly. First, we will begin looking at how many we have on both sides of the equation, how many on the reactants, and how many on the products. Next, we can begin to balance the equation and find that it is already balanced. It is equal on all sides.
Most rockets use a solid fuel engine. Once ignited, it burns at a steady rate that can't be controlled. It represents the chemical reaction of rocket fuel. Our solid stage is one piece of uncooked pasta, which alone burns really easily. For the liquid, we'll take advantage of a simple chemical reaction, which is hydrogen peroxide, H2O2, and mix some yeast with it, a little teaspoon of yeast, and we'll produce pure oxygen as the yeast breaks the hydrogen peroxide into oxygen gas and liquid water. And the equation for this is H2O2 plus C6H12O6 yields O2 plus H2O. Okay, I have the jar full of peroxide to right here, and I put about a teaspoon of yeast or so, and it started bubbling, and it got up to like right here, as you can see. I'm gonna get a lighter, and the pasta is right here, and I'm gonna light it on top of it.
In this equation for the hybrid pasta rocket, it is essentially the same as the first experiment, which undergoes the decomposition of hydrogen peroxide. H2O2 yields H2O plus O2, which is balanced to 2H2O2 yields 2H2O plus O2.